Good morning, friends. Welcome to the second session of day 2, March 27th. In this session, we have 4 talks by Umesh Srinivasan, Ashwin Vishwanathan, T. Ganesh, and Parveen Sher. We start with the talk by Umesh Srinivasan entitled Insights from a Decade of Monitoring Bird Populations in the Eastern Himalayas, drawing on his incredible 10-year record of birds in Eagle Nest Wildlife Sanctuary. So we can play the video now.
Hello, my name is Umesh Srinivasan, and I am from the Center for Ecological Sciences at the Indian Institute of Science. And what I'm talking about today is a bird monitoring program that we have been running for the last 10 years in Arunachal Pradesh, trying to understand how climate change and forest degradation affects the survival of birds in this region in the Eastern Himalayas. Uh, because of climate change, a lot of species in tropical mountains are actually shifting their elevational ranges upwards. So they're moving from lower elevations to higher elevations. And we think that the reason they're doing that is to try and remain within the kind of temperatures that they are adapted to. At the same time, while they're moving upwards, they also face habitat degradation. So one example of habitat degradation that you can see on the panel on the right is selective logging. And that is the practice by which a subset of trees that are commercially important are removed from the forest, changing the structure of the forest. So the top right, you can see a forest that has never been disturbed, whereas on the bottom left, you can see a selectively logged forest. And both climate change and selective logging operate jointly. Birds do not face these threats in isolation or separately. They're actually facing both these threats together. So it's important to understand for the survival and the persistence of these bird species, how do climate change and habitat degradation operate jointly to affect survival rates in these species? And the way we have been studying this is using mist netting and bird ringing at 2,000 meters in elevation. And that's where we have the maximum number of bird species in the Eastern Himalayas. So if you look on the right, at 2,000 meters, we have a set of plots that have been established in primary forest outlined by green and selectively logged forest outlined by red, where we have been doing mist netting every year in the breeding season from 2011 onwards, and this will be our 11th year of doing that. And each of these white arrows represents the location of a mist net. Now, mist net is a near invisible net that's placed in the habitat, and birds fly into these nets and they get captured. And we remove the birds from the nets and we place a numbered aluminum ring on their leg, and we release them back into the habitat. So you can see here a green-tailed sunbird that's been released after being ringed. And each of these rings has a unique number. So we are able to identify individuals of birds because of bird ringing. Now, what we do is we go back to the same plots year after year in the breeding season, place nets at exactly the same locations. And based on the number of recaptures of birds we get, that is, birds that have been ringed in previous years and captured again in the current year, and the number of new captures we get, which is birds that have never been ringed before, based on that data that we collect, we can estimate the survival probabilities of these different species. And like I said, we've been doing this over the last 10 years. So we have some idea how survival rates are changing over time at 2,000 meters for a number of bird species populations in primary forests and in selectively logged forests. So with climate change, what we would expect to see at 2,000 meters is that if you had a bird species like the blue one, where the most of the elevational range of the species is below 2,000 meters, that is 2,000 meters is close to the upper edge of its elevational range, then this species should start moving up in response to climate change towards 2,000 meters in elevation. And therefore, it's moving up towards more suitable temperatures as the climate is warming, and survival rates should increase over time for species like the blue species. On the other hand, you have species like the yellow one, where the elevational range of the species is such that the lower end of the elevational range is close to 2,000 meters. Survival rates of this species at 2,000 meters should decline because of upslope movement in response to climate change. What we are finding is what we expect, at least in primary forests. So in this panel on the right, there are two graphs for two different species, the snowy brown flycatcher on top and the white-tailed robin below. On the x-axis is time, so going from 2011 to 2018. On the y-axis is survival rate. So a survival rate of say zero point 0.2 means that 20% of the population survives from one year to the next. The green lines indicate the survival trends in primary forest on our primary forest plots, and the brown lines indicate survival trends in log forest plots. Now, the snowy brown flycatcher on top is a higher elevation species like the yellow one that you see on the left. And over time in primary forest, the decline in survival rates is consistent with the idea that these species are leaving the 2000-meter elevational band and moving further upwards. The white-tailed robin below is a lower elevation species, and the rise in survival rates in primary forest is consistent with the expectation that these species are moving up towards 2000 meters to habitats that are more thermally suitable for them. So in primary forests, we are seeing changes in survival rates that are consistent with upslope movement of birds in these mountains. However, we're not seeing that happening in log forests, and the reasons for this remain unclear. But I just want to highlight, for example, the white-tailed robin here. So while primary forest survival rates are increasing over time and increasing very quickly, survival rates in log forest are not able to keep up as much as with survival rates in primary forest. So it seems as if, at least for species like this, while they move up, primary forest is necessary for them to move into to adapt to climate change. Whereas if they encounter degraded habitats, they might not be able to maintain their survival rates. So it's likely that to enable species to remain resilient to climate change in the future, we will need to have primary forests across entire elevational gradients so that they move up into primary forests and can maintain survival rates. Whereas a species that move up into degraded forests like this from below might not be able to maintain survival rates. I'll stop here. Thank you very much. And I'll be happy to take any questions now. Thank you.